Okay. My name is Ki Zhang. I'm from UC Davis. I'm a graduate student. Well, before I start, I'd like to thank for the committee for giving me this opportunity to present our work here. As a member of the routing group in the DeterIMIST project, I'm working on the BGP emulation testbed setup and try to evaluate current BGP security techniques. In this talk, I will briefly introduce our testbed. DeterIMIST project aims to create, support, and maintain a collaborative experimental environment for the cybersecurity research. For routing group, the major focus is to build a medium-scale BGP routing experiment and BGP routing testbed to emulate the realistic operational environment and eventually evaluate the BGP security mechanisms. So to do this, in our testbed, we have a module which can recreate the routing dynamics in the testbed, and we also install a module to artificially launch the attacks. And additionally, we also have the module which can combine the statistical-based anomaly detection with interactive visualization techniques to profile, characterize, and visualize and interpret the BGP event. Okay, let's take a look at the whole picture of our testbed. So, DeterLab basically is built based on the EmuLab, which is a PC-based cluster. Currently, in the DeterLab, a user can have up to 93 nodes to build an arbitrary topology network and do whatever he wants in each node. And for the routing group, we install the GNU Zebra in each node. So potentially, we can have up to 93 Zebra router. And beyond this PC cluster, we also have a few commercial routers, including Cisco 12000 and 2600. In the testbed, the background BGP traffic is very important. So we inject the real-world BGP traffic collected from the origin route wheel. Currently, we only inject traffic from one pair, which is AS1239, operated by Sprint. So as a result, we can see all the routes used by Sprint. And we also install our anomaly detection engine in some special node to analyze the traffic, and the examined traffic can be viewed by the visualization front end. We also have the module which launched the attack. Here's the two-screen snapshot showing our visualization front end. The upper left window picturing the BGP dynamics, and the right bottom window shows how the origin AS changed in the whole internet. For example, if there is a prefix which changes its origin AS from one to another, then we'll draw a lens in the square. Here, I'd like to give an example to show how this visualization tool can help users to explore and interpret the hidden information existing in the traffic, in the BGP traffic. In April 6, 2001, a small ISP in London, they claim that they own thousands of prefixes. Actually, they belong to other areas. And one day later, they realized this mistake, and they began to withdraw the bad announcement. Well, it takes them 6 days to fix this problem. And our visualization tools, looking at that data, and can capable capturing this event. And in this case, I do want to emphasize that if you really look at the raw data manually, there are thousands of events. So it is very hard to know what happened in those days. But with this interactive visualization process, it is easier for user to know what happened, and also this tool can correlate the thousands of events into just one instance. And in our testbed, we also have developed a strategy which can combine the statistical-based anomaly detection with the interactive visualization techniques. Basically, our detection engine is to profile the long-term normal BGP data by looking at some specific measures. And after this training, this engine examines the new dataset by looking at the same measures and compare the new dataset with the profile dataset. An alarm will be sound if a significant difference is found. And this detection engine also attach this statistical information into the original raw data and feed into the visualization front end. So the visualization tool can not only show the raw data, but also display the statistical information. And also, because we all know that for the statistical-based anomaly detection, sometimes it is very hard to determine some critical parameters such as threshold. And in our experiment, with this visualization tool, sometimes it's easier for user to determine that threshold, because this interactive process can combine not only the machine knowledge, also the human knowledge. Here, I do like to mention two experiments we did in this testbed. First is the origin AS change. We actually did the similar thing as the small London ASP did. And the second one is related to the route flag dampening. Well, basically in our experiments, we show that an attacker can take the advantage of the route flag dampening. So he can remotely cause the router to suppress a route. Because I don't have so much time, so I won't go into detail of the experiment. But one thing I do want to mention is that, remember we have in our testbed, we have the PC-based Zebra router and also some Cisco routers. We did the dampening experiments on both platforms. Although an attack can take effect on both platforms, we still find some interesting things. We found that actually the Zebra router and the Cisco router, they behave very differently when we launch the same dampening attack. So that actually suggests us that maybe in our testbed we should include more vendors' products. So in our testbed we can make it as realistic as possible. At last, I would like to introduce my colleague, Sung Ti Teo. He's the author of the visualization tool, and he will be happy to show you the demo offline. And I think he will show demo on the labs there, after this talk. Thank you very much.